Hi, boys and girls. Welcome to room 9. It's Mrs. Crawford again. I think this is day 3 of you and I together learning and talking about and doing some work with fractions. And before we start, let me do my shout out today. My shout out is going to go to my 4th graders that were in my class this year. My school only goes up to 4th grade, so they're getting ready to go to a whole new building for 5th grade, and I'm gonna miss them. We didn't get a chance to do some of the things we usually do, but we had a great parade for them, and I can't wait to see all the things they do in 5th grade. So shout out to 4C19. Have a great summer, guys, and kill it at the 5th grade center. Okay, so we've been talking about fractions all week long, and yesterday we did some comparing of fractions, and we got a chance to work our multiplication skills out with comparing fractions so that we could get the denominators to be the same. So we're going to start with the word problem. Yes, a word problem. So let's take a look here, because these kind of things happen in real life. We use fractions in real life. And we've got Mark and Dale here. So let's read it together. Mark and Dale ordered pizzas that were the same size. Mrs. Crawford made a mistake here. That should be Mark ate, not Mark at. So let's put an E on there. Mark ate 3/8 of his pizza. Dale ate 1/4 of his pizza. Who ate more pizza? Okay, so there's a couple of ways we could go about figuring this out, right? Are you in your mind already doing some things to figure it out? I bet you already know, don't you? Okay, so why don't you do this? If you have them, you can take out your fraction strips that we made on the very first day together. We can use that to help us. And remember, Miss Crawford has her secret fraction strips herself. So let's start with how much Mark ate of his pizza. So it said he ate 3/8. Can I ask you a question? Which is larger, 1/8 or 1/4? Which is larger, 1/8 or 1/4? Well, remember when we're talking about fractions are parts of a whole. And a fraction has 2 parts, right? There's a numerator and a denominator, right? The numerator is our top number, and our denominator is our bottom number, okay? So the numerator tells us how many parts, and our denominator tells us what our whole is. So back to my question. 1/8 or 1/4? Which is more? You're right. 1/4 is going to be greater than 1/8. We had that example we've been using all week of the pizza. I mean, not the pizza, the brownies, the pan of brownies. And if I have a pan of brownies that I am sharing, right? And I am sharing it, and I have 7 friends. There's 8 of us all together. My part, my one piece of the 8 is going to be smaller than if it's just me and 3 friends. So there's 4 of us all together. My part is going to be bigger if I only have to share with 4 as opposed to sharing with 8. Okay, so let's go back to the question here. Mark ate 3/8. I said Mark Keith because that's my son's name, but we call him Mark. There's 3/8. And Dale ate 1/4. Who ate more? Yeah, Dale had less. Mark was hungry. He ate more pizza than Dale. So we can look at it like this. We could draw it out. We could use our fraction strips to look at it. Let's look at it like we did yesterday with our math, okay? And we have our fractions here. 3/8 compared to 1/4. Do you remember what we said we wanted to do? We need to get the numerators, we need to get the denominators to be the same. We need to get them to be the same. And in order to do that, we're going to have to multiply the denominators by a number. And whatever we multiply the denominator by, we are also going to multiply the numerator by. And they're going to give us an equivalent fraction. So let's do our counting. If we skip count by 4, what numbers do we say? Because that's going to let us know what our denominator can be, our common denominator. Common denominator is going to come from a common multiple. So we say 4, 8, 12, 16. Let's stop there because I realized you realized something, didn't you? Yeah, if we skip count by 8, we start with 8. So it's going to stay 3/8, right? Because if we say we only counted once, then we still have just the fraction 3 times 1 is 3 and 8 times 1 is 8. It's still 3/8. But how many times did we count by 4 to get to 8? 2 times. So if we multiply times 2, 1 times 2 is 2, so that numerator is now 2, and 4 times 2 is 8. Now, we can compare that, can't we? 3/8 and 2/8. Well, the denominator is the same, right? Look at this. 1/4 is the same as 2/8. And we can see that if I only have 1/8, if I have 2/8 compared to having 3/8, right? I have eaten less if I am Dale, right? So let's write this out. 3/8 is greater than, I did the right one this time, guys, 1/4. It's a word problem. We've got to give an answer. Who ate more pizza? Mark ate more pizza. There we go, guys. Good job. Good thinking today. We're going to have to keep doing some of that same type of thinking because we are going to be doing equivalent fractions. This 2/8 being the same as 1/4 is actually our very first example here. So let me put this to the side. Okay, I realized before we move to the big board, let's go back to this small board. I wanted you guys to be able to do some more work with your fraction kit that we made on the first day together. So let's go ahead and pull your kit out and you can lay out your pieces the way that you see here, or at least have them set up so that you can see them. So we're going to use our kit to compare some fractions. And so I'm going to give a few fractions and we're going to try to make equivalent fractions to those. So our first one is going to be 3/5. 3/5. What does 3/5 look like as a fraction? Well, the numerator is 3 and the denominator is 5. Right? 3/5. Okay, so that tells us we have 3/5. So there we go. We have 3/5. Now, we want to know how many tenths does it take to equal the 3/5. So we are looking at tenths. I think some of you have already started doing some math work in your head. That's a good job, because we can go back to how do we make the denominators the same, can't we? Well, before we do that, let's go ahead and count up our tenths. So 1/5 is, how many tenths do we need to make 1/5? Okay, I'm going to slide this down here so we kind of have, so 2 tenths is equal to 1/5. So I've got 3/5, so I need another set of 2. So that gives me 1, 2, 3, 4 tenths. And another set of tenths. 1, 2, 3, 4, 5, 6 tenths is equal to 3/5. 6 tenths is equal to 3/5. Well, what do you notice? I thought you would catch on to this. You know that if you multiply the denominator 5 times 2, you are going to get 10. And if you multiply your numerator by 2, because whatever you multiply your denominator by, you have to do the same to your numerator, you're also going to get 10. You're also going to get 6. So we would end up with 5 times 2 is 10. 3 times 2 is 6. Alrighty, so we're proving ourselves right here. Are you ready for another one? Okay, so let's get rid of this and let's go to thirds. I am thinking, let's do thirds. And I am thinking, how many thirds is this right here? Can you give me an answer? 2/3, very good. And let's see twelfths. How many twelfths do we need to make it to 2/3, to be equal to 2/3? So we're looking at twelfths. Look how small that is. Okay, so let's go. Let's see, how many twelfths does it take to just equal 1/3? Look at that. You need 1, 2, 3, 4 twelfths to equal 1/3. You're right. 3 times 4 is 12, and you need 4 of those. So if I've got another third, I need how many twelfths over there? I've got tiles, fraction tiles all over the place. How about you? It's okay. It's the work we're doing today. You need another 4. So 4 plus another 4 is 8. So 2/3 is equal to 8/12, or 8/12 is equal to 2/3. Well, you noticed, right? If you multiply your denominator 3 times 4 of those 12, right? 4, then you would end up with 12. Let's give us some room here. 3 times 4 is 12. 2 times 4 is 8. 8/12 and 8/12. Alrighty, let's do one more, and that's going to take us here. That's our fourths. Okay. If we have 1/4 is what we need to look at. How many eighths, right? 1/4. And looking at how many eighths do we need to equal the 4th. So let's go ahead and put it up there. Did you already start doing the math? You multiplied by 2, didn't you? So you already see. You are so good. You're seeing that work in your head already. If we multiplied our denominator by 2 and our numerator by 2, we would get our answer that we have here with our fraction tiles. 2/8 is equal to 1/4, right? 4 times 2 is 8. 1 times 2 is 2. Very good. So that's the work that we're going to continue right now on our big board. I like fraction tiles. Fraction tiles makes it really easy for us to see. So I have done my best to make equal parts. It's a bit of a challenge, but I think we have it here. So we're gonna have to do some filling in, shading in order to get these fractions to be. So I'm going to give you your fraction, and your first one is 1/4. So I have my square here, and I have 4 parts, 2, 3, 4, and I'm shading 1 part of 4. Now, when we talk about equivalent fractions, we are talking about having the same amount of space covered of a whole, even if the denominators are different, even if we have a different amount of our whole being placed into different parts. So for instance, this square is into 4 parts. But look at this square, same size square, and it has 1, 2, 3, 4, 5, 6, 7, 8 parts. Now, how many parts do I need shaded in order to equal the same amount that is shaded in for 1/4? Well, if you take a look, you may see that even though it's 8 parts, I can still see 4 parts in this, right? There's a 3rd part and a 4th part. So how many do I need to shade in to equal the same amount shaded as a 4th? Very good. I need to shade in 2. So this fraction would be how many parts shaded out of how many parts total? 1, 2, 3, 4, 5, 6, 7, 8. 2 parts shaded, your numerator, out of 8 parts total. Okay, so let's do it with this one. How many parts do we have here? 1, 2, 3, 4. Okay, let's shade in 2/4. 2 of the 4. 2 of the 4 equal parts. Okay, 2/4. Now, this is a whole, and it has how many parts? 2. So my denominator is 2 because that's the number of parts that I have. Now, how many parts do I shade in to equal or to have the same amount of space covered as my 2/4? Do I need to shade in both parts? No, you're right. I only need to shade in 1 of those parts. And if I shade in just 1 of the 2 parts, my numerator is 1. What's that fraction? 1/2. Very good. So we could say 2/4 is equal to 1/2. 2/4 is equal to 1/2. So let's put an equal sign in there between these two, right? Okay, let's do another one. We have 1, 2, 3, 4, 5, 6. Let's do 4/6 on this one. So we're going to shade in how many of the 6? 4. Okay. 1, 2, 3, and 4. Okay, so 4 parts of the 6 are shaded. Now, I don't have 6 here. I have 3 parts. So how much of this do I need to shade to have the same amount of space covered? Okay, very good. You need to shade in 2 parts. Very good. Okay, so what's this fraction? How many parts do you have shaded? 2. And how many parts total are there? 3. Very good. So 4/6 is equal to 2/3. Alrighty, are you ready for the last one down here? Okay, let's do this. Let's go back to the green. It's like a spaceship, doesn't it? Alrighty, how many parts do I have and how many parts are shaded in? Okay, so very good. There are 3 parts shaded in and there are 3 parts total. Okay, so let's look at this one. I don't have 3 parts, I have 6 parts. Well, how much do I need to shade in to match the amount that I shaded in on the other triangle? Yeah, you're right. I need to shade all of it in, right? So if you shade in all 6 parts, what is your fraction? Well, go back to what you know. The numerator tells us how many parts, and denominator tells us what is the whole. So there are 6 parts and 6 altogether. 6/6. So 3/3 is equal to 6/6, which when we look at it is equal to 1 whole. Very good. Very good. Did you catch what you did with the denominators, going from one denominator to the other in order to make an equivalent fraction? Very good. On here, you're right. You multiplied 4 times 2 and 1 times 2. Very good. Which one did you have to do, would you do here? Would you multiply by the denominator 4 or would you multiply the denominator 2? Very good. You want to get the 2 to be the 4. So you will multiply times 2 times 2. Is this true or false? 2 times 2 is 4. It's true. True or false? 1 times 2 is 2. It's true. Very good. Let's look here. 6 and 3. Do you need to change both or just one? Very good. You would change just the 3. 3 times 2 and 2 times 2. True or false? 3 times 2 is 6. It's true. And 2 times 2 is 4. It's true. What about here? 3 to 6. Very good. You would multiply the 3 times 2 and the 3 times 2. True or false? 3 times 2 is 6. It's true. And 3 times 2 is 6. That's true. All right, boys and girls, that's it for us today. So remember that fractions are parts of wholes, okay? That the numerator is the part, denominator is the whole. It tells us how many our whole is divided into, how many parts is divided into. And when we are looking at comparing fractions, if we can get the denominators to be the same, then it makes it easy to compare our fractions, okay? Well, I will see you tomorrow. I think tomorrow's our last day together this week, but I'll see you. Bye.